Hi, my name is Dr. Bhutia and I'm from BSc Second Sem, and my topic for today is laser. So we're going to talk about laser, and laser stands for light amplification due to stimulated emission of radiation, and this laser is different from an ordinary light. When a laser is being emitted from a device, it goes in a particular direction, whereas when a light is emitted from an ordinary source, it goes in many directions. So light laser, and my topic for today is helium neon laser. Helium neon laser. So there are certain characteristics which are necessary for laser, and those characteristics are as follows. Fluorescence, and the second one is high intensity. High directionality and high monochromaticity. So these are the characteristics necessary for a laser. So first of all, laser is high. These are all the properties that a laser consists of, and hence, because of this property, lasers are used in medical as well as industrial purposes. And this laser was first this helium neon laser was the first gas laser. This was the first gas laser, which was this was the first gas laser invented by Ali Javan and his co-workers. In a Bell laboratory in USA in 1961. So laser beam is emitted in a particular, we know that laser beam is emitted in a particular wavelength, and whereas an ordinary light is of different wavelength. And now we're going to talk about construction of neon laser. So for construction of neon laser, we have this kind of apparatus. And let's say M1. This is M1 and this is M2. And these are the electrons, and so this is this apparatus in which we may produce helium neon laser, and inside this tube, which is known as narrow discharge tube, it contains helium and neon. It contains helium and neon, this narrow discharge tube, and helium is in the ratio, and helium and neon are in the ratio 10:1. And these are the mirrors, mirror 1 and mirror 2. This mirror 1 is fully reflecting, whereas mirror 2 is partially reflecting. Mirror 1 is so what are the purposes of this mirror is that it produces resonating cavity. And these are the electrodes. In this system, we use electron pumping method. Instead of optical pumping method, because in this the acting medium is gases, and for gases we need to electrically, we need to add electrons in its atoms, or we need to electrically charge the atoms of the gas molecules. Hence we use electrical pumping method, and through these electrodes we supply DC voltage in it. We apply DC voltage in it. And the laser beam which is being produced is not due to helium, but it is due to neon. Hence neon is also known as lasing gas. Neon is known as lasing gas because the laser which is being produced is because of neon. And helium in this tube, discharge tube, narrow discharge tube, helium is in 1 meter of Hg pressure, whereas neon is in 0.1 mm Hg pressure. And when we electrically charge the gases present in the narrow discharge tube, helium gets charged first, because helium atoms are lighter than neon atoms. The mass of helium atom is about 4, whereas for the mass of neon atom is about 19 or 20, which is four times more than that. Hence helium atom gets charged first because of electron collision, and then the energy gets transferred from helium to neon. And we're gonna discuss that later on. And this narrow discharge tube is about 25 to 100 centimeter in length. This is about 25 to 100 centimeter in length, and its diameter is about 1 centimeter. So it is very narrow. And this is the system for which helps us to make helium neon laser. And we're gonna discuss its working now. So now we're going to talk about the principal working and energy level diagram. So basically here it is an energy level diagram of helium and neon inside the small narrow discharge tube. So when we supply DC voltage in electrode, the electrons, they charge or excite the helium atoms by electron collision. So by electron collision, they excite the helium atom, and the helium atom from its ground state goes to an excited state, which is 2's or 2,3s. And from that, once the helium atom gets excited, as I said, the first atom to get excited is helium atom, and once it gets excited, it transfers the energy. Which is known as resonating energy transfer. So it transfers the energy from 2's to 3s, and then from there is a transition. Once the energy gets transferred from helium atom to neon atom, the neon atom from its ground state goes to its excited state, and from there it leads to transition of those energy, and the energy gets transferred in various states. For example, when the energy goes from this 3s state to 3p state, the photon produced is 3.39 micrometer. When the energy is transferred from this 3s to 2p, the energy produced is 6325 angstrom. And when the energy is transferred from this 3s to this from 2s to 1s, from 2s to 1s, the photon produced is 1.15 micrometer. So this is how the energy transfer system works. The DC voltage is supplied in an electrode, and it excites the helium atom first. And the helium atom gets excited due to electron collision, and the helium atom goes from its ground state to its excited state, and we see a resonating energy transfer from helium atom to neon atom. And then in neon atom, since we know neon is the reason laser beam is being produced, neon transfers its energy in different states or transition, and various photons are produced. So the photons which are produced from 3s to 3p, and the photons which are produced from 2s to 1s, the photon produced is 1.15 micrometer and 3.39 micrometer respectively. These photons are useless as it lies in the infrared region. There is no friends, so there is no laser formed. So the photon produced by the transfer of energy from this 3s to 3p and from 2s to 1s, the photon produced is useless as it lies in the infrared region, and there is no currents and no lasers. So hence no laser is being produced. But when the energy is being transferred from this state 3s to 2p, this photon produced 6,632.5 angstrom. This photon produced goes to and fro in the mirror of the system. It goes to and fro of the system, and hence the laser is being produced. So this is how the system inside the narrow discharge tube works. And we use helium and neon mixture rather than any gas mixture because their energy levels are comparable. And this is how the working of that system works. So, and we can explain this working in a single equation, and that equation is helium plus electron E, and E equals to neon plus helium. So this is the necessary reaction. So this is the equation which also explains this system. What it says is helium atom gets excited because of electrical collision, and this excited helium transferred its energy to neon. So this equation alone explains this entire system. So this is the principal working and energy level diagram of helium neon laser. So now we are going to talk about the advantages and disadvantages of helium neon laser. The cost of helium neon laser is very cheap. So to construct the helium neon laser, it is very cheap. And the construction of helium neon laser, second point is the construction of helium neon laser is not that complex. So it's simple to make. It provides safety due to low. Since helium neon laser, the output is less, so we can say it is safe. So, and it is of small length, and the best life helium neon laser can give is about 20,000 hours. So it is of small length, and it gives good lasting. It produces three wavelengths. 1.15 micrometer, 3.39 micrometer, and 632.8 nanometer. And the wavelength of this 632 nanometer, it gives a visible red light, which is of many uses. For example, we can use it in emergency places, in many bars and many purposes. And its disadvantages are it takes a longer warm-up time. So in order to for this laser to work, it takes a long time to warm up. As we said, it has an advantage purpose of low output power. It is safe, but the output generated is very low. It is a low gain system or device, and high voltage requirement can also be considered a disadvantage of this system. And escape of gas from the plasma tube can also be considered as its disadvantages. So these are the advantages and disadvantages of helium neon laser. Now we're going to discuss the applications of helium neon laser. So the first application is the narrow beam of helium neon laser, which is in red color or of 632.8 nanometer, can be used in supermarkets and reading barcodes and and the second application is it is used in holography and helps in producing the 3D image of the object. Third is it has many industrial and scientific uses, but it is mainly used in laboratory for demonstration of optics. And last is it is used in guns for aimings and various purposes. Thank you.